This is Praful. Good evening to everyone. Hope you all are doing great, guys. Guys, before starting this session, I would like to ask you one question. And question is, how many of you know how we identify devices in network? Like how many types of addresses we have in the network? We identify our friend with name. Like this, how we identify devices in network? Definitely there will be some kind of addresses, right? So may I know how many types of addresses are there in the network? Please write down your answer in chat. Then I will start the session. Today topic is types of addresses. But before starting the session, I have to connect this class from the previous class. Like in previous two classes, we discussed OSI model and application layer protocols. So I'm checking chat. Some people are saying IPv4 and IPv6. No. IPv6 and IPv4 both are logical address. Kiran Patel is saying IP address and MAC address. Very good. There are two types of addresses in network. First one is MAC address and second one is IP address. Now my second question to you guys is, what is the difference between MAC address and IP address? Please let me know answer of this question also in chat. Physical and logical addresses, definitely. So MAC address is your physical address and IP address is your logical address. So what is the difference between MAC address and IP address? Why we have two types of address? Layer 2 and layer 3. Okay. MAC address is physical address, NIC ID, and IP address is assigned by the router to access the internet. Okay, to identify device and network. Okay. MAC address is layer 2 address and IP address is layer 3 address. MAC address is physical address. This address can't be changed. This is very good, right? MAC address is permanent address. Okay, may I know how many MAC addresses are there in your laptop? How many MAC addresses are there in your laptop? In your laptop, tell me how many MAC addresses are there? One? One? No, not one. But okay, that is fine. It depends. It depends on how many way we have to connect my laptop to network. Like I can connect my laptop to network through LAN card. So there will be one NIC card there, and on the NIC card MAC address is hard coded. No voice. Am I audible? I'm audible, guys. Yes, I am audible. So MAC address is okay. First difference is MAC address works at layer 2, IP address works at layer 3. Second difference is any second difference like size. What is the size of MAC address? What is the size of IP address? So if a laptop have 5 NIC, that means that laptop have 5 MAC addresses. 64 bits address? No. MAC address is 48 bits hexadecimal, represented in hexadecimal. 48 bits hexadecimal, okay. And IP address? IP address is 32 bits address. So second difference is MAC address size is 48 bits and IP address size is 32 bits. IPv4. Now we are not talking about IPv6. We are not talking about IPv6. We are talking about IPv4. There are two versions, right? In in logical address, one is IPv4 and one is IPv6. Now we are talking about IPv4 addressing. We are not talking about IPv6 addressing. Public and private No, that is different thing. We divide IP addresses into some classes into public and private. We will understand why and what is the reason behind it, how we subnet everything. For now, our concern is only to understand address, types of address. So we understood we have two types of address. One is MAC address and another one is IP address. MAC address works at layer 2, IP address works at layer 3. MAC address is 48 bits address and IP address is 32 bits address. MAC address is provided by MAC MAC address is provided by manufacturing company. Like if you are using a laptop of HP, so HP have already hard coded MAC address on an IC card and they put the NIC card in your laptop. Because of that, you are able to connect your laptop to network. Because of that only you are able to connect your laptop to network. IP address provider and who will provide IP addresses to device? Network engineer. Network engineer will provide IP address to machine. MAC address, manufacturing company, IP address, network engineer. So if someone will ask you who will provide addresses to devices, so it depends. We are talking about which type of address. Now I am sharing my screen. Topic is types of addresses. So we have two types of address. First one is MAC address. MAC address also known as by physical address, hardware address. Address and second one is IP address. Great. Yes. Okay, fine. First, we will understand MAC address, then we will start IP address, and after that, we will see subnetting. And we will understand why we come up with subnetting, why we need to divide IP address into some classes, why we need to divide IP address into private and public, and rest thing. So, topic is MAC address. First, we are going to understand MAC address. So, guys, as I told you, MAC address is 48 bits address. MAC address. It is an 48 bits address. Now there are two parts in this 48 bits address. There are two parts in this 48 bits address. One is first part is OUI. OUI stands for Organization Unique Identifier. Organizational Unique Identifier. First 24 bits. See, if you will divide entire MAC address into two parts, so you will get 24 bits plus 24 bits. So first 24 bits of a MAC address is called OUI, Organizational Unique Identifier, right? And last 24 bits is called vendor assigned. That depends on vendor company who is manufacturing device. Vendor assigned. Fine. So how we represent this MAC address? How we represent MAC address? So we represent MAC address into hexadecimal notation. Represented in hexadecimal. How many of you know how many characters are there in hexadecimal? 16 characters are there. 0 to yes, 16 characters are there. 16 characters are there. 0 to F. 0 to F. So my MAC address can be what? My MAC address can be 0, 0. How many times 0? 1 0 carry how many bits? 1 0 carry how many bits? See, if you will see MAC address of my device, like if I will show you MAC address of my device. See, are you able to see this MAC address? This is MAC address. Let me copy this MAC address. This is one MAC address. This is MAC address of my laptop. This is. How many characters are there? 2, 4, 6, 8, 10, and 12. 12 characters are there in one MAC address. And one character carry how many bits? 4 bits. So 4 multiplied by 12. Total length of MAC address is 48 bits. 48 bits. Fine. So my lowest MAC address can be what? My lowest MAC address can be 00, 00, 00, 00, 00, 00, and 00. This is my smallest MAC address. It can be a smallest MAC address 12 times 0. This is notation. Notation can be like this also. Notation can be like this also. Notation can be like this also. Like there are now 3 fields, and each field is separated with dash. Or here we can remove this dash also. All are same. There is no difference between this MAC address and the previous MAC address. Both are same. And the largest MAC address will be what? 12 times F. 12 times F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is largest MAC address. That means all MAC address is going to lie between this range. Right? This MAC address, you can see this MAC address is between this range. Fine. So this MAC address is inside this range. So all MAC address will lie in this range. So let me write one MAC address here. AB12 hyphen, or I can use semicolon. Any notation here I can use. AB12, 1, 2, 3, 4, and 1, 2, 1, 2. This is a valid MAC address or invalid MAC address. Is it a valid MAC address, guys? Please let me know in chat. Let me see. Is it a valid MAC address or not? Yes. Yes, it is valid MAC address. Yes, absolutely yes. This one is valid MAC address. Or I can represent this MAC address like this also. Here I can replace it. There is no any difference between this and previous MAC address. Here also I can say like dash. Here also I can write down dash. Here also I can write down dash. All MAC addresses are same. The difference is in representation only. In all MAC address there are 12 characters, and each character carry how many bits? 4 bits. So total length of MAC address is 48 bits. Now try to understand how we are using MAC address. So let me take one example of any company. Let's say Dell. Dell is manufacturing networking devices, as you all know, like laptops. Okay, so if Dell is manufacturing laptop, they need to put an IC card, and inside the NIC card they need to hard code MAC address. They need to hard code MAC address like this. You can see this is permanent MAC address of which? On wireless LAN adapter. On my wireless LAN adapter, this MAC address is hard coded. This MAC address is hard coded by company. This is Lenovo laptop. So Lenovo have hard coded this MAC address on my wireless LAN adapter. On my Ethernet, adapter, you can see this is MAC address. Both are different. On Ethernet, port or on Ethernet NIC, there is different MAC address. On wireless NIC, there is different MAC address. So we are able to see two MAC addresses in my laptop because here I have two NIC, and here you can see there are some more also, like this is virtual Ethernet for VM wireless, and you can add NIC card also. So if you will add NIC card, that means you are adding one interface to connect your computer to network. Right? So how Dell or Lenovo or HP or any company is designing MAC addresses. So first, company need to purchase OUI from an organization called INA. INA is the organization, guys, who is managing these things like MAC addresses, IP addresses, private IP, public IP, right? In some video in upcoming day, maybe we will discuss more about INA. It is this is an organization who is managing entire internet. So INA is selling what? OUI. OUI, Organizational Unique Identifier. This is what? 24 bits of a MAC address. So let's say they'll have purchased one OUI from INA, and that OUI is what? Let's say 000. 24 bits means how many character? 6 character, right? Let's say 000 and then 00, or let me use colon here. This is OUI that they'll have just purchased from INA. Now INA need to design one MAC address. Sorry, they'll need to design one MAC address for their first laptop or for their first NIC card. So what Dell will do? Dell will decide last 24 bits of this MAC address. Who will decide first 24 bits? INA, that is OUI, Organizational Unique Identifier, and last 24 bits will be decided by manufacturing company. So let's say here, Dell have assigned last 24 bits, that is 0, 0, then 0, 0, 0, 1. So now this is a complete MAC address. This is now 48 bits MAC address, and now Dell can assign this MAC address to one NIC card. To another NIC card, what Dell will do? Dell can design another MAC address also with the help of same OUI. OUI will be same, but last 24 value will be different. Here I am going to change value here 2. Now you can see both MAC addresses are different, not same, but OUI of both MAC addresses are same. OUI of both MAC addresses are same, but vendor assigned means last 24 bits different, right? So now question is, Dell can design how many NIC card with the help of single OUI? So with the help of single OUI, Dell can design 2 to the power 24 MAC addresses, because Dell have how many space? 24 bits. So Dell can design how many computer, how many NIC card? 2 to the power 24 from one NIC card. So always keep in mind, from one OUI. So always keep in mind, with the help of one OUI, you can design 2 to the power 24 NIC card. And last MAC address of this OUI will be what? 0000 colon 0000, not 00. This is OUI. After that, F. This is last MAC address of this OUI. This is last MAC address of this OUI. Now after this MAC address, again they'll need to purchase one more OUI, right? So Dell can design 2 to the power 24 MAC addresses with the help of one OUI, and after that they need to purchase again OUI from INA. And INA have record that I have already sell this OUI to Dell, so I will not sell this OUI to any other company. I will not sell this OUI to any other company. So this is why MAC address is globally unique. This is why MAC address is globally unique. Let me take one example of another company, let's say HP. Here HP is also going to manufacture their computers, so they need MAC addresses. They will purchase OUI from INA. Let's say HP have purchased one OUI, that is 0000001. You can see this OUI and OUI of Dell is different. Both are different. And now HP need to design first MAC address for their first NIC card. So they will assign last 24 bits value 0001. Right? You can see here OUI of Dell and HP is different, but vendor assigned means last 24 bits of Dell and HP is same. Last 24 bits of Dell and HP is same. Still MAC address of HP and Dell is unique. Why? Because of OUI. Because OUI is different. And now again HP can design how many NIC, how many MAC addresses with the help of this OUI 2 to the power 24. And last MAC address will be 000. They can't change any value in OUI. Right? Here F. This is last MAC address of HP. Fine. So this is how MAC addresses are globally unique. Fine. So a laptop or any NIC card have globally unique MAC addresses. Can we change MAC address of any PC? No, you can't change MAC address of any NIC card. If you want to change MAC address, you have to change NIC card. What attacker or hacker these guys are doing? These guys are changing NIC card. If you will do any illegal, on internet, so anyone can trace your device, can trace your laptop with the help of what? MAC address. With the help of MAC address. Because MAC address is globally unique. Fine. Is it clear, guys? Please let me know in comment if MAC address is clear or any question from MAC address so that I can start IP addressing. This is all about MAC address. MAC address is 48 bits address. We represent it in hexadecimal format, or notation can be anything. Like if I will talk about notation of representation of MAC address in Windows operating system. So you can see this is how we represent MAC address in Windows operating system. If I will show you how we represent MAC address in Cisco IS, so you can see here in packet tracer. I can show you in packet tracer MAC address. Cisco represent. Yes, see here. Let me do one thing. I'm going to show you MAC address on router interface. Or anywhere you can check, doesn't matter. Just I want to show you how Cisco IS represent MAC address. So here also you will see total number of character in MAC address is 12. So interface fast Ethernet 0/0. Let's say you can see MAC address. Hardware address is this one. This is how Cisco represent MAC address. Let me put it here. Yes, this is, see, there is no any difference. There are 3 fields. In some iOS you can see in Windows operating system 1, 2, 3, 4, 5, 6. 6 fields are there. In Cisco IS 3 fields are there. But total number of characters are 12. Fine. Okay, so this is first type of address. This is first type of address, MAC address. MAC address is divided into two parts, OUI and vendor assign. OUI is first 24 bits and vendor assign is last 24 bits. OUI will be decided by INA and last 24 bits, that is vendor assigned, depends on manufacturing company. With the help of one OUI, a company can design 2 to the power 24 MAC addresses. And all MAC addresses are globally unique. And you understood how all MAC addresses are globally unique. You can see Dell and HP both are using same vendor assigned. Last 24 bits is same. Last 24 bits in both MAC addresses are same, but OUI is different. OUI is different. Because of that, both MAC addresses are unique. Fine. Now next type of address is IP address. IP address. IP address. So IP address is 32 bits address. First think about IP address. It is an 32 bits address. Guys, how we represent IP address? How we represent IP address? How we represent IP address? Yes, let me know in the chat how we represent IP address. Like we represent MAC address in hexadecimal. How we represent IP address? We represent IP address in dotted decimal. We represent IP address in dotted decimal. Let me write here. Represented in dotted decimal. Fine. We have 4 fields in IP address. 4 fields in IPv4 address. So if we have an address of 32 bits and we divide that address into 4 fields, that means each field will carry how many bits? Tell me in comment section, in chat. Each field will carry how many bits? 8 bits. Very good. Because definitely 8 bits, because total length of IP address is 32 bits and we have 4 fields. So 4 multiplied by 8 equals 32. And with the help of 8 bits, tell me, with the help of 8 bits, what minimum decimal value I can write down, or what maximum decimal value I can write down? What minimum and maximum value I can write down with the help of 8 bits? Like if all bits are 0, that means definitely I will get what? Lowest value 2, 4, 2, 4, 6, 7, 8. With the help of 8 bits, we can, if all bits are 0, that means decimal value is going to be 0. If all bits are 1, then I will get maximum value 1, 2, 3, 4, 5, 6, 7, 8. Now I will get what? Maximum value. That is 255. If you will convert this binary into decimal, you will get 255 here. So one field will carry value between 0 to 255. One field of IP address will carry value between 0 to 255. 0 to 255. Minimum value can be 0 and largest value can be 255. That means my lowest IP address can be what? 0.0.0.0. Means all bits are 0. In first field, all bits are 0. In second field, all bits are 0. In third field, all bits are 0. In fourth field, all bits are 0. And my largest IP address can be what? 255.255.255.255. When all bits are 1. When all bits are 1. Then what decimal value I will get? 255.255.255.255. See, if you don't know IPv4 addressing, so first it is an 32 bits address. We divide it into 4 parts. Each parts carry 8 bits information. Each part carry 8-bit information, and with the help of 8-bit information, we can represent decimal value from 0 to 255. Minimum value will be 0 and maximum value will be 255. So my lowest IP address can be 0.0.0.0. My largest IP address can be 255.255.255.255. All IPv4 addresses will lie in this range. All IPv4 address lie in this range. Okay. And how we separate each field? With dot. With dot. Here you can see I am separating each field with dot. So we separate each field with dot. Fine. So now here I am writing one IP address, guys. Let me ask you this question: 10.1.1.1. Is it a valid IP address? Is it a valid IP address? Yes or no? Yes, yes, yes. Okay, let me write another IP address: 10.256.1.1. Tell me about this one. Is it valid IP address? No. Wrong. No. The question is why? Why this IP address is not a valid IP address? Because as I told you, each field carry 8 bits information. In second field, you can see in second we called field to octet also. We called one field to octet also. Octet, because each field carry 8 bits information. So with the help of 8 bits, you can't write down 256. We can't represent 256 with the help of 8 bits. So because of that, this IP address is invalid. So sometime interview is also asking this type of question. They will, write down one IP address in front of you, and they will ask you, this IP address is valid or invalid. This IP address is valid or invalid. And if you will say this one is invalid IP address, they will ask you why. What is the reason? So reason is very simple, because in second octet value is 256, and this is not possible with the help of 8 bits. We can't write down 256 with the help of 8 bits. Fine. This is the reason why this IP address is invalid. Right. Now, how many total number of IP addresses we have? 2 to the power 32. Total number of, if I will talk about total IP addresses in the world. So 2 power 32 only. 2 power 32. But we need more than 2 to the power 32 IP addresses because of population. Population is greater than this value. We are using multiple IP addresses. We have multiple devices like laptop, mobile, car key. Nowadays, car key also need one IP address. Getting my point? So IPv4 address is not sufficient. Getting my point? IPv4 addresses are not sufficient because we have only 2 to the power 32 IP addresses, and we need lots of more IP addresses. So what I will do? First, we come up with technique called dividing IP addresses into classes. Dividing IP address into classes. So we divide IPv4 address into some classes. Till now, what we discussed? We discussed IP address is an 32 bits address represented in dotted decimal. We have 4 fields in IPv4 address. We separate each field with dot, and each field carry 8 bits information. So value in one field can be 0 to 255. My lowest IP address can be 0.0.0.0. My largest IP address can be 255.255.255.255. Means my all IP address is going to lie between this range 0.0.0 to 255.255.255.255. This is a valid IP address. This is a valid IP address, and the lower one is invalid IP address. You know the reason. Now see the classes. As I told you, why we come up with classes first? To avoid the shortage of IPv4 addresses. To avoid the shortage of IPv4 addresses, we divide this address into some classes. So now who tell me how many classes we have in IPv4 address, guys? How many classes are there? Please let me know in comment.
You.
Class A, we divide this 32 bits address into some classes. First is class A, second one is class B, second one is class C, third one is class D, and last one is class E. So we have 5 classes in IPv4 addressing. See, I must tell you, class D and class E is not for you. These two classes are not for you, for network engineer. Class D is used for multicasting and class E is used for research, like ISRO, NASA, right? These research center use IP addresses from class E, and this class D is used for multicasting, like when you will learn OSPF routing protocol or other routing protocols, you will see all routing protocols are using one multicast address. So for that multicasting, we reserve class D. As a network engineer, you need to work on upper 3 classes: class A, class B, class C. As a network engineer, you will work on these 3 classes: class A, class B, class C. Now may I know what is the range of class A? Very good. Yes, tell me the range of class A. 0 to 126. 0 to 126, okay. 0 to 127, 126, 64, not 64. 0 to 127 or 126. Okay. What is the range of class B? 127 to 191. Okay. Can anyone tell me how we divide IP addresses into classes? How we divide IP address into classes? Like on the basis of what we divide IP address into classes? On the basis of what we divide IP address into classes? On the basis of value, on the basis of value present in first octet, or you can say in first field. Let's say here I am writing one IP address. Here I am writing one IP address, that is, let's say 10.10.10.1. So this is my IP address, and I need to identify this IP address belongs to which class: class A, class B, class C, class D. So I need to check value in first octet. Value in first field means first field is this one, this field. What is the value in first field? That will determine this IP address belongs to which class. This IP address belongs to which class. So in first octet, value is 10. That means this IP address belongs to class A. So we divide, if someone will ask you how we divide IPv4 address into classes. So we divide IPv4 address into classes with the help of value present in first octet. And the value present in first octet also, what we did, to define a range to each class, we reserve some bits. Like for class A, for class A, how many bits we have in first octet? 8 bits. So out of 8 bits, we reserve first bit. We reserve First bit. That first bits will be always 0. First bits will be always 0. Now how many bits left? How many bits are left in first octet? 7. So if all 7 bits is going to be 0, then value will be what? 0. And if all 7 bits is going to be 1, 2, 3, 4, 5, 6, 7, then value will be what? 127. Then value is going to be 127. That means range of class A is 0 to 127. Range of class A is 0 to 127. Range of class A is 0 to 127. Any IP address whose value belongs to this range in first octet are IP address of class A. Okay. For in the same way for class B also, what we need, we reserve 2 bit. First bit will be always 1 and second bit will be always 0 for class B. Now how many left bits are there in class B in first octet? How many left bits are there in first octet? 6 bits are left. So if all 6 bits are going to be 0, then value will be what? 128. If all rest bits means 6 bits is going to be 1, then value is going to be what? 191. So this is range of which class? This is range of class B. So if I will talk about range of class B, so range will be 128 to 191. This is range of class B. Fine. For class C also, what we did? We reserve 3 bits. First bits will be always 1, second bit will be also 1, and third bit will be always 0. So these 3 bits are reserved for class C. How many left bits are there? 5. So if all 5 bits is going to be 0, then we will get what value? 192. And if I will set all rest bits 1, then what value I will get? 22. What value I will get here? What value I will get here if I will put these all bits 1, 2, 2, 3. Very good. So this is going to be range for class C. So for class C, range is 192 to 223. Fine. Okay. So now guys, I'm asking you one question here. Let me check you guys have understood class or not. So I am writing one IP address here, that is, let's say 150.1.1.1. This IP address belongs to which class? Tell me, this IP address belongs to which class? Class C? No, class B. Class B, very good. Okay, this IP address belongs to which class? 0.0.0.1. Very good. Class A. 1.255.1.1. This IP address belongs to which class? Not class B. Why class B, brother? If you need to identify this IP address belongs to which class, you will check value present in first octet. If value in first octet is 1, that means this IP address belongs to class A. If value in first octet belongs to this range, that means that IP address belongs to class A. If value in first octet belongs to this range, that IP address belongs to class B. If value in first octet belongs to this range, that means that IP address belongs to class. That means that IP address belongs to class C. Okay. So let me write one more IP address here, 192.168.10.1. This IP address belongs to which class? Class C. When people saying class B, no brother, why class B? Class C. This is class C IP address. Why? Because see, value in first octet is 192. 192 means in value existing in this range. That means IP address belongs to class C. That means IP address belongs to class C. Okay. So this is classification of IPv4 addressing. Now, next thing is, you know, all IPv4 address, like here I am writing one IP address 10.10.10.10. This is a valid IP address, and this IP address belongs to class A. Now, 172.10.50. Which class? See, 172 belongs to which range? 172 belongs to which range? Class B. Very good. Very good. Now, let's talk about this side. Let's talk about this IP address. Now, this IP address belongs to class A, and this is a valid IP address, right? This IP address is combination of two things. This IP address is Y reserved bits in first octet, just to divide IP address into classes. And why we divide IP address into classes? To reduce the shortage of IPv4 address, because total number of IP address is 2 to the power 32, around 3 million. But we let's see the devices, world population. So according to that, we need lots of more IP addresses. We have shortage of IPv4 address. So that's why first we divide, to reduce the shortage, first we divide IP address into classes, then we divide IP address into private and public, then we come up with subnetting, then we come up with NAT, and then we come up with IPv6. Then we come up with IPv6. So this was first, method to reduce the shortage of IPv4 address, dividing it into classes. Okay, welcome. So this IP address is combination of two things. This IP address is combination of two things: network ID and host ID. Network bits and host bits. IP address, each and every IP address is combination of two things. One is network bits and another one is host bits. Network bits and host bits. Fine. Any IP address like 10.10.10.10, there are some network bits, there are some host bit. Now, who is going to differentiate or identify how many network bits are there and how many host bits are there? Now, if someone is thinking what is network bits and what is host bits and why we have network bits and host bits in one IP address, why not only network, all bits are network bits or all bits are host bits? So you will understand this also soon. What I'm saying, each and every IP address is combination of two things: network bits and host bits. Who is going to differentiate? How we are going to identify how many network bits are there and how many host bits are there? Is there any tool? Is there any marker who can specify there are 8 network bits or 24 host bits? That is what? That is not subnet. That is subnet mask. That is subnet mask. Subnet mask. So what is subnet mask? Someone can ask you guys, what is subnet mask? So subnet mask is a tool, or you can say subnet mask is a marker which specify how many network bits are there and how many host bits are there in a particular IP address. In a particular IP address. How many network bits are there and how many host bits are there in a particular IP address. It is a tool or marker which specify how many network bits are there and how many host bits are there. Network bits means 1 and host bits means 0. If bits is 1, that means that is network bits. If bits is 0, that means that is host bit. So subnet mask is going to specify how many network bits are there and how many host bits are there in a particular IP address, and we have a predefined subnet mask for each class. May I know what is the predefined subnet mask for class A? Yes, for class A, predefined subnet mask is 255.0.0.0. See, in first octet value is 255. That means all bits in first octets are 1. That means there are 8 network bits, and in last third field value are 0. That means 24 bits are host bit. That means 24 bits are host bit. All 24 last 24 bits are 0. If I will convert this value into binary, so binary will be like this: 1 1 1 1 5 6 7 8. Then 8 times 0, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. This is binary of this subnet mask, right? This is binary. So how many ones are there? 8. And how many zeros are there? 24. So how many network bits are there? 8. And how many host bits are there? 24. In the same way for class B, tell me guys, what is the predefined subnet mask? For class B, 255.255.255.0.0. Right? So here you can see in first octet all bits are 1, means 8 bits are 1. In second octet all bits are 1, means total 16 bits are 1 and 16 bits are 0. That means total 16 bits are network bits and 16 bits are host bits in class B. Yes, tell me for class C also. Okay. Class C 255.255.255.0. Now you can see here 24 bits are 1, means network bits, and 8 are host bit, right? So if I will talk about network bits in class A, number of network bits n equals 8 and h equals host bit equals 24. If I will talk about network bits in class B, how many network bits are there? 16. And how many host bits are there? 16. For class C, how many network bits are there? 24. And how many host bits are there? 8. This is predefined subnet mask for each class. Now, again, I am going to write one IP address here, and my IP address is 192.168. Let's say 1.1. First of all, first question is it a valid IP address? Yes. Okay. Then this IP address belongs to which class? Class C. Now, how many network bits are there? 24. Okay. And how many host bits are there? 8. 8 host bits are there. 8 and 24 network bits are there. What will be the subnet mask for this IP address? 255.255.255.0. Very good. Now, guys, this is a IP address. This is IP address. We can assign this IP address to NIC. To NIC card, we can assign this IP address. But this IP address belongs to a network. Definitely belongs to, like, you are member of a family. You are member of a family, right? Who is head member of your family? Maybe your father, grandfather, like this. This is a particular IP address. This IP address belongs to a network. Now, who will tell me what is the network of this IP address? What is the network of this IP address? What is the network ID of this IP address? This IP, or interviewer can ask you, this IP address belongs to which network? 192.168.1.255. No. Network ID of this IP address is 192. Yes, very good. This last one, 192.168.1.0. This is the network ID of this IP address. Getting my point? So how we find network ID? To find network ID, you need to convert IP address and subnet mask into binary. Then you need to perform AND operation. Then you need to perform AND operation on subnet mask and your IP address to get network ID. Like if I will convert 192 into binary, so binary of 192 will be what? 11 and 0006. 6 times 0. This is binary of 192. May I know the binary of 168, guys? Binary of 190, 168. Binary of 168 is 1010100000. This is binary of 168. Binary of 1, 000000001 and 0000567 8. This is binary of my IP address. Now I am going to convert my subnet mask into binary. So subnet mask is this one. This one is subnet mask. If I will convert 255 into binary, I will get this in binary all 1, 4, 5, 6, 7, 8. This is binary of my subnet mask. Here also 4, 5, 6, 7, 8. Here also 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. This is binary of my, sorry, this is last octet value is 0. All bits are 0 here. 1, 2, 3, 4, 5, 6, 7, 8. And now on this you will perform AND operation. After AND operation, in AND operation, 0 is going to be 0, 1 is going to be 0. Let me write here. 0 is going to be what? 0. 1 is going to be 0. 1 is going to be what? 0. 1 is going to be 1. Right? This is AND operation. So here we need to perform AND operation. Here we will perform AND operation. AND operation. So after AND operation, see 1, 1, 1 and 1. Here we will get what value? 1, 1, and then 0 and 1. 0, 0, 0, 0, 0, 0. This is result after AND operation. Right? So why I am getting same value? Because I am multiplying this value with 1. So if you will multiply any value with 1, you will get same value. Here also I will get same value. 1, 0, 1, 0, 1, 0, 0, 0. Then 0, 0, 0, 0, 4, 5, 6, 7, 1. And in last octet, all, see, I am multiplying this into this, means in subnet mask all bits are 0. So here I will get all 0. 4, 5, 6, 7, 8. So this is your network ID. This is what? Network ID. See, this is IP address. This is IP address. This is subnet mask. This is subnet mask. And this is result after AND operation. There is no any difference between this IP address and this IP address. Both are same. Right? Difference is this IP address is represented in decimal and this IP address is represented in binary. Both are same. This subnet mask represented in decimal and this subnet mask represented in binary. Fine. And now again we need to convert this value into decimal. So see, this is what? 192. This is 192. This is 168. 168. This is 1 and this is 0. Means my network ID is what? 192.168.1.0. This is how we calculate network ID. This is how we calculate network ID, how we find network ID of an IP address. Fine. Is it clear, guys? How to find network ID? If this is clear to you, then tell me 10.10.10.10. This IP address belongs to which class? Very good. What is the subnet mask? 255.0.0.0. Very good. What will be the network ID? What will be the network ID? Please calculate the network ID and let me know what will be the network ID here. 10.1.0.0. No, this is incorrect. 10.0.0.0. See, if you will multiply this 10 with what? 255 means all bits are 1. You will get same value. But when you will multiply second octet value with 0, that value will be 0 there. Here also value is going to be 0. Here also value is going to be 0. You can try it. But you can convert 10 into binary 0001010 dot. Let me copy it. 10.10.10.10. And then we need to convert subnet mask into binary. So subnet mask is here all 1, 8. Here all bits are 0. Right? And now we will perform AND operation on this. So after AND operation, I will get what value here? 0.000.10.10 dot. I will get all value 0 here, all bits 0, all bits 0, all bits 0. So what decimal value I will get? 10.0.0.0. So this is my network ID. This is my network ID. Okay. This is my network ID. Okay. Let me check. Let me show you it in book also. So here you can read about IP addressing, guys. The detailed information about IP addressing, like why we come up, classes or binary to decimal convergence is also there. Bits, bytes. So you can see for class A, we have 8 bits for network and 24 for host. For class B, we have 16 bits for network and 16 bits for host. For class C, we have 24 bits for networks and 8 bits for host. Class D is used for multicasting. Class E is used for research. Then network address class A range, you can see 0 to 127. For class B, what is the range? For each class, you can read the range also. Class A valid IP address. Okay, and now I would like to discuss one very interesting question. Question is very simple. Question is, how many network I can design from class A, guys? How many network I can design from class A? See, this is question of CCNA exam paper. How many network I can design from class A? From class A. For class A, how many bits? How many network bits we have? 8. No. No. See, we have 8 network bits for class. We have 8 network bits for class A. But out of these 8 bits, we already reserve 1 bits for dividing it into classes. So total number of free bits in class A is total number of free network bits in class A is 7. That means we can design 2 power 7 network. 2 power 7 network from class A. For class B, how many network I can design? For class B, how many bits, network bits we have? We have 16 network bits for class B. But out of 16 bits, we have reserved 2 bits. How many free bits we have for class B? 14. That means 2 to the power 14 network, 2 to the power 14 network. I can design 2 to the power 14 network from class B. And from class C, again for class C, how many network bits we have? So we have 24 network bits for class C. But out of 24 bits, I have reserved 3 bits. Right? Like here, I have reserved 3 bits. So total number of free bits are 21. That means I can design 2 power 21 network from which class? From class C. Yes, 2 power 21. Okay. After that, you can read this document for better understanding. Then we divide IP address into private and public. And you can see the range. What is difference between private IP address and public IP address? We divide again, see, first we divide IP address into classes to reduce the shortage. Again, we had shortage. So what we did, we divide IP address into now private and public. Public. Private is non-routable. Yes, private IP addresses are non-routable on internet, and public IP addresses are routable on internet. Private IP addresses are free of cost. Generally, we are using private IP address inside the network, in the private network, LAN, local area network, and we are using public IP address on internet, on the public network, on the WAN side, right? As I told you, there are major two types of network, LAN and WAN. LAN is inside your private network. So in your private network, you will use private IP address. In WAN side, we will use public IP address. So from each class, we have a range for private IP address or for public IP address. So this is range of private IP address. This is range of private IP address. Let me put it here. See the range. For class A, range is 10.0.0.0 to 10.255.255.255. Right. This is what? Private IP address. So if I will write one IP address here, guys, my IP address is, let's say, 1.1.1.1. Now I am asking, this IP address belongs to which class? Again, same question. This IP address belongs to which class?
Class A.
Class A. Very good. And this IP address is private or public?
Public IP address.
Public IP address. Very good. That means this IP address is for WAN, for internet, not for LAN. And what will be the network ID of this IP address? 1.0.0.0. Why? Because subnet mask is 255.0.0.0. Getting my point? Again, I am writing one IP address here, 10.10.10.10. This IP address is private or public?
Private.
Private. This is private IP address. That means we will use this IP address in my inside network, in LAN. Right. So now if I will show you the IP address of my laptop on wireless adapter, you can see my private IP address is what? This one. DNS server, gateway. My gateway IP address is this one, correct? And see, this IP address belongs to class C. But we need to identify this is a private or public.
Private.
Private. Because private range for class is 192.168.0.0 to 192.168.255.255. So any IP address from this range is private IP address for class B. Sorry, for class C. Right. So what can do here? 172.16.30.1.30.1. This IP address is private or public?
Private.
Private.
No. Private range is starting from, yes, this is private. Okay, let me correct it. This one. This one is a private or public?
Public, sir.
8.8.8 is public, no, brother? See, 8, first octet value is 8. That means this IP address belongs to class A, and for class A, private range is 10 dot. IP address is starting from 10 dot, but 8.8.8.8. This is the public IP address. Okay. 192.10.1.1. This is a private or public?
Public.
Public.
Very good. This is a public IP address. Right. And after that, see, first we divide IP address into classes, then into private and public. Still, we had shortage of IPv4 addressing. So then we come up with
Subnet.
subnetting. Then we come up with subnetting. Then we come up with subnetting. So what is subnetting? Subnetting is, see, before understand the requirement of subnetting, why we need subnetting. See, I need to design one network. Let's say I am a network engineer in a company. In that company, my manager told me to design one network of 50 people. They need 50. They need to connect 50 computers together. So I need to design one network with 50 computer. My requirement is what? I need how many IP address? 50 IP addresses. And my manager give me this network ID 192.168.1.0/24/24, or you can say subnet mask 255.255.255.0. My manager told me you need to design a network where we need 50 hosts. We need to connect 50 hosts, and you need to use IP address from this network. You need to use IP address from this network. So can anyone tell me how many IP addresses are there? How many valid IP addresses are there in this network?
254.
Definitely here we will get 254 IP addresses. How? See, there is one formula, very easy. 2 to the power h minus 2. Formula to calculate valid host is this one. 2 to the power h minus 2, where h is h equals host bit. Host bits. So here I need to find valid host. So what I will do, I will use this formula 2 to the power h. What is h? H is host bit. How many host bits are there in this subnet mask?
24.
24 or 8?
Eight.
Sir, 8.
8. So 2 to the power 8 minus 2. 2 to the power 8 is 256 minus 2. You will get 254 valid IP addresses here. So, okay, I need 50 IP address here. Let's say this is my switch. And here I am connecting 50 computers, and I will assign IP addresses to all from this range 192.168.1. Let's say I have assigned IP addresses to machine from 1.1 to 192.168.1. Let's say 50. Last computer IP address is this one, and first computer IP address is this one. And let's say this switch is connected with one router here, and in future, same company need to connect some more computer this side. They need to design one more network here. Here they place one switch, and they need, let's say, how many IP addresses? 20. They need to connect 20 computer here. 50 host is required here. How many host is required here? Host 50, and here how many host is required? Let's say 20 host. Here we need 20 host. So can I assign IP address to machine from same network? Can I assign this IP address? Let's say this device, this switch is connected with one router here like this. Both network are directly connected with each other. This is my router R. And can I assign 192.168.1.51 to computer in this network in right side? Answer is no.
No, sir.
Because both host belongs to same network. Both host belongs to same network. If you will find network ID of this IP address, if you will calculate network ID of this IP address, network ID is 192.168.1.0. Network ID of this IP address is also 192.168.1.0. Both network ID is same. Router connect different network together. Router connect different network together, but here we are using same network both sides. So this is not possible. That means this organization can not use, REST IP address in their another side. In their another side. That means this organization need to use different network here. Let me, here they need to use different network. They can use like this network 192.168. Let's say 20.0. Yes, they can use this network. Fine. But this side, left side, you have wasted how many IPv4 addresses?
So 200, 250, 204,
Around
204.
200. Yes, around 200. So just to reduce this 200 IP addresses, we come up with
Subnetting.
subnetting. So why we come up with subnetting? To reduce the wastage of IPv4 address. To reduce the wastage of IPv4 addressing, we come up with subnetting. With the help of subnetting, I can divide this large network into a smaller network. This is a large network. There are 254 IP addresses, but I need, let's say, only 50 IP addresses. So I can divide this network. But without subnetting, we can not divide a network. For class B, if you will pick any IP address from class B, let me tell you once 10.1.1.0 or 1. Or network ID is, let's say, 10.0.0.0. This is class A IP address. This network belongs to class A. This is subnet mask. So you can see in this network there are lots of IP addresses. How many number of IP addresses are there in this network? 2 power
24 minus 2.
2 power 24. Now you can see how many hosts are there. Their huge number of IP addresses. Am I right? 2 to the power 24 minus 2. Huge number of IP addresses are there. But if you need to design a small network, if you need only 20 IP addresses, right, then what you need to do? You need to divide the network into a smaller part. Because by default, size of network is, but definitely if my network size is small, then I will use IP addressing from class C, because from class C I will get less number of IP address. If my network size is large, I will use IP address from class B. If my network size is huge, then I will use IP address from class A. But still, let's say my network size is less than 200 users. Then we need to what? What we need to do? We need to do subnetting. Or we need, let's say, 500 IP addresses. We need subnetting. If I will use by default IP address, then from class A, I will get 2 power 24 minus 2 IP address by default. For class B, by default I will get 2 power 16 minus 2. Am I right? And for class C, 2 power 8 minus 2. This is by default IP addresses from each class. But after subnetting, you can get 10 IP address, 50 IP address, 60 IP address, 100 IP address. Okay, so the reason why we come up with subnetting is to divide large network into a smaller network to reduce the wastage. Okay, now what is subnetting? So subnetting is the process of dividing large network into a smaller network. Fine. So let me give you one example. 192.168.1.0. This network belongs to class C. Subnet mask is 255.255.255.0. See, in subnetting, what I will do, I will borrow network bits. If I will convert this subnet mask into binary, then binary of this subnet mask is 4, 5, 6, 7, 8, and again 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. Right? This is binary of this subnet mask. Now, if I will change this value, see this value. If I will replace this 0 with 1, then what will happen? Now, can anyone tell me what will be the subnet mask?
255.255.255.128.
255.255.255.128. Very good. This is now subnet mask. So if now you will, check network ID. So again, what you will do, you will convert IP address and subnet mask into binary. Then you will perform what AND operation to find network ID. But this is still a network ID. So I have borrow one bit. I have changed one host bits into network bits. That means I have divided this network into two parts. See, there is one again more formula. Formula is number of network. How to find number of network? 2 to the power n, where n is
Borrowed host bit.
yes, borrowed host bit. By default, see, when subnet mask is this one, 255.255.255.0. How many bit I have borrow? 0 bit. So if you will put n value 0, so 2 to the power 0, what value you will get? 1. That means how many network are there? 1. But if I have borrow 1 bit, that means n is now 1. Means total number of network is now 2. Total number of network is now 2. Right? If I will borrow 2 bit, this bit also, let's say 1, then now n is what? N is 2. Number of borrow bit is 2. So now total number of network is 4. If you are dividing network into 2 part, 4 part, that means valid host is also reducing per network. Earlier there was one single network. That's why we were getting 254 valid hosts. Now we have 2 network. So valid host is divided into 2 part now. Valid host is divided into two parts now. Right. So let me show you guys how we are doing subnetting here. For that, what I will do, just wait. One 192.168.1.0, and I'm going to borrow one bit. Then my subnet mask will be 255.255.255.128. And see, I need to find number of network first here. Number of network. So number of network will be 2 to the power n. N is borrow bit. Here I have borrow 1 bit. That means 2 to the power 1 is 2. This total number of network is going to be 2. Then valid host. How to find valid host? Formula is, 2 to the power h minus 2. Now what is h? How many h is there? How
7.
many host bits are there?
7.
7. So this time 2 to the power 7. 2 to the power 7 is 128 minus 2. Now you can see valid host is what? 126. Earlier valid host was 254. Yes, now valid host is 126. Okay. So my first network, how we will find network? See, my first network will be this one, 192.168.1.0, and my second network will be 192.168.1. See, you need to find in which octet last bits is present. So last bits is present in which octet? Fourth octet. In fourth field, you can see last one is present in fourth field. I'm talking about subnet mask, guys. In subnet mask, last one is present in fourth octet, right? So in fourth octet value is 128. That means last one is there. That means I need to add block size in fourth octet to find next network. This is very clear and crystal that this is first network. But what is next network? So to find next network, you need to add block size here. And formula to calculate block size is 256 minus subnet mask of last octet. Subnet mask of last octet. Subnet mask of last octet is what? 128. Subnet mask of last octet is 128. So this is my block size. You need to remember only these three formula. How to find number of network, how to find valid host, and how to find block size. You can solve all questions of subnetting. So now my block size is 128. I can add my block size where value is changing, where last one is present. So here I will add 128. That means this is my first network. This is my last network. Second network. What can be the third network? To find third network, again I will add block size in fourth octet, because last one is present in fourth octet. So if I will add 128 to 128, I will get what value? 256. Is it valid? Is it valid? No.
No.
This is invalid, right?
And also we need only two. No, we can get only two
Yes.
networks. So we are
Correct.
done.
Correct. So what will be the last IP address of first network then? 192.168.1.127, because next network is starting from 128. That means definitely this network is ending on 127. Yes or no, brother? Then only this second network is starting from here, 128. And second network will end on what IP address? 192.168.1.255. Yes or no? Because next network is starting from 256. That is not valid. This is not valid. But here, this is my two network now. What will be the first valid IP address of first network? 192.168.1.1. What is the last IP address of first network? 192.168.127. And second last network, IP 128. 6. Right. What is the first IP address of second network? 192.168.1.129. And what is the last IP address of second network? 192.168.254. Now you can see valid host in first network is 126. Valid host in second network is 126. Because we can't use this IP address because this is network ID. First IP address is network ID and last IP address is network ID. Broadcast ID. Right? Broadcast ID tell us where your network is ending and network ID tell us from where your network is starting. We are not allowed to assign network ID and broadcast ID to NIC. So first usable IP address is this one, last usable IP address is this one in first network. First usable IP address in second network is this one and last usable IP address in second network is this one. So here we have total 126 IP address, usable 126 IP addresses are there, and in second network also we have 126 IP address, right? Now if I need to design one network where I need, let's say, 50 hosts, so I can use this subnet mask 255.255.255.128, but still I am wasting lot of IP address. So what I can do to reduce more? I can do one thing. I can borrow more bit 192.168.1.0, and this time I am going to borrow 2 bits. 2 bits. By default, subnet mask is 255.255.255.0.
192.
I am going to use 255.255.255.192. That means I have borrow 2 bits. So again, I need to find all things like block size, number of network, and valid host. So first of all, tell me number of network.
4.
Number of network 4 because 2 to the power n. And n is means borrow bit. How many bits I have borrowed? 2 bits. So number of networks will be 4. Valid host will be what? Valid host per network 2 to the power h. H is
62.
62. H is what? How many host bits are there? 6.
6.
6. And 2 to the power 6 is
64.
64. So 64 minus 2. That means 62. Then block size. Block size. 256 minus subnet mask of last octet. 192. What value you will get here? Please subtract 192 from 256.
64.
Very good. So my first network will be this time. My first network is going to be 192.168.1.0. Second network is going to be 192.168.1. Block size 64. Third network 192.168.1. 64 plus 64. 128. And then 192.168.1. 128 plus 64, 192. So see, we have 4 networks. And what will be the last IP address of first network? 192.168.1. 63. 63. What will be the last IP address of second network? 192.168.1. 127. What is the last IP address of third network? 192.168.1. 191. And last IP address of fourth network 192.168.1. 255. Right? But these are not usable IP address. First usable IP address is 192.168.1.1. From second network, First valid IP address is 192.168.1.65. Third IP address is first IP address from third network is 192.168.1.129, and first valid IP address from third network is 193. Getting my point? Last IP address 192.160. Here last. One 192.168.1.62. 192.168.1.126. 192.168.1.190. 190. 192.168.1.254. So here in first network, guys, how many valid hosts are there? 62. 62. Here also 62. Here also 62. And here also 62. So now if I will use this network for my requirement, like I need 50 hosts. So I can use network, this network or this network, any network from here. So I will get only 62 valid IP addresses. I will use 50, and okay, if I am wasting 12 number of IP addresses, that is not big challenge, and we can reduce that 12 also. That is VLSM. Subnetting is dividing large network into a smaller network uniformly. Means length of each network is equal. You can see I have divided this network into 4 parts, and length of all network is equal. So this is fixed length subnet masking. Fixed length subnet masking, FLSM. What we call it, FLSM. And we have one more term, that is VLSM. If length of your network is variable, let's say you need 4 network, but length of each network is not equal, not uniform, then you need to do VLSM, that we will see in another video. Okay, so today we understood how we identify devices in network with the help of address, how many types of address we have, and we understood MAC address, we understood IP address, we understood classification, we understood subnet mask and subnetting. Now this is time of Q&A. If anyone have question from today class, please ask. Otherwise, that's all for today, guys. And if